All right. Our first weak acid question. All right. We are going to take everything we learned from equilibrium in chapter 15, and we're just applying it to weak acid systems. You've already done these calculations. Hopefully you already feel like you have them under your belt. And so now this is just equilibrium calculations for a specific system. My hope is that it doesn't feel that scary. Okay, so let's start. Like, you might not look at this and say this is an equilibrium question, because right, what is the pH of a formic acid solution? Okay, well, the thing that tips you off to say this has got to be an equilibrium question is that I give you a big K value. I give you the acid dissociation constant. Okay, so that's telling us something about when formic acid goes into solution, some of it dissociates, but not all of it, which means that we have a dynamic equilibrium with some undissociated and some dissociated, and they're going back and forth, and the concentration is constant. So I like to, even though like on the exam, you don't have to do this, but every question like this, I like to just start off by writing down the reaction that's happening. So HCOOH is our acid, and it's in an aqueous solution, which again, I didn't specify because I never think to. Aqueous at room temperature, okay? And it's going to dissociate, okay? Some of it will break up into H plus, and we'll have HCOO minus left over. Okay, and it's gonna go back and forth. To know the pH of the solution, when you say, hey, we're asking for pH, what you're being asked for is the H plus concentration at equilibrium, right? That is what we need to know to calculate pH, how much H plus is there in solution. All right, so to set this up, we are going to use an ice table, just like we did when we had, when we were doing non-weak acid equilibrium questions. Ka equals, and now I can write an expression here. Okay, and I want all of these to be equilibrium values because that's what K is defined as, and we know that that equals 1.8 times 10 to the negative fourth. That's a small number, so I should have a lot more of my reactant than my product, okay? So I'm starting with initially 2.5 molar of HCOOH. We're going to say we have 0 of our H plus and HCOO minus. We're thinking about this as like you just put it in there and none of it has dissolved yet or dissociated. Okay, so we have some change. So we're going to lose some of this and we're going to gain H plus and HCOO minus. Okay, so we'll have 2.5 minus X, X, and X. We are going to start using our 5% assumption that the dissociation, that X is so incredibly small that we can drop it in this expression almost for every weak acid question. Okay, so this is really going to be 2.5. Okay, and we'll come back and check that. We're going to use what's called the 5% rule. Okay, so I'm going to take my equilibrium values now and plug them in here. Okay, so I have Ka equals x squared over 2.5. And I'm going to solve for x. Okay, and x equals my H plus concentration. It also equals my A minus or my HCOO minus concentration. But since I'm trying to calculate pH at equilibrium, I'm thinking about this as H plus. Okay, so x equals 1.8 times 10 to the negative fourth times 2.5, and we're going to take the square root of that. So it's the square root of Ka times Ha initial. Okay, if our assumption works, if this is a good assumption here, you can jump here pretty quickly when you're doing these calculations. Okay, so let me punch this in here. Okay, so I got an x equal to 0.021. And we just want to check, was that a good assumption? Is it much less than 2.5? Like, was this a good assumption? And yeah, 0.021 is way smaller than 2.5. If you want to quantify it, we do our 5% check. Okay, so 2.5 minus 0. I'm not going to do it that way. I'm going to do it this way. 0.021 divided by 2.5 times 100%. So that divided by 2.5 times 100, this was a mere 8.8%. So much, much less than 5%. So yes, that means that the math is going to math for us. It didn't really matter that we dropped that X term there because it was so small. So I feel good about this number. I can now use that as my H plus concentration and go ahead and calculate my pH. I got 1.68. I'm going to go back up and put 1.68. If you want to double check yourself, rather than going through and punching in all these numbers again, which like you might just make the same mistake over again, here's my exam check. I'd go say, okay, Ka must equal 0.021 squared divided by 2.5. Okay, and I check to make sure that that gives me the Ka that was provided in the question. And I got 1.76, which rounds to 1.8 times 10 to the negative fourth. So I feel really good about this calculation and I feel confident, especially on these numerical questions where you have no feedback, like you have no multiple choice question answers to be like, my answer's there. That's good feedback that I got the right answer, as long as you didn't get one of our distractors. So when you have these numerical questions, go back and do a different check to make sure that you can reproduce one of the numbers provided to you in the question. That's a really, really strong way to check your work on the exam.